All right, let's do it. Let's do some practice. Calculating our pHs and our OHs and all that sort of thing. If we're given, say, a solution, let's say our solution is 0.0262 molar HCl. HCl, as we know, is a strong acid. So HCl dissociating, or we can say put with water, goes to completion. There's no equilibrium that happens here, or the equilibrium is so far to the right that we don't really see any of our reactants hanging around. Of course, except for the water, because that's our solvent, but the HCl will be completely gone. It'll completely break up. That means that if this was 0.262 to begin with, the stoichiometry tells us, well, then these must also be 0.262. Right? It's just dissociation. And so, because this is a strong acid, because HCl is strong, we're going to have an H plus concentration equal to 0.0262 molar, because it's a strong acid. Next week, when we look at weak acids, we have quite a bit more work to do to try and figure out the H plus concentration of a solution of a weak acid. But because HCl is strong, we get to avoid that, and we can go ahead and just use our H plus directly. So with that in mind, we can calculate a few things. First things first, why don't we calculate the pH? We just learned how to do that. So pH, remember, is negative log of H plus. So if we do that, this will be the negative log of 0.0262. So let's go ahead and bust out our calculators. Negative log 0.0262. We get 1.582. Don't forget your sig figs. pH has no unit, so don't forget that as well. So we've got it. We've got our pH here. And of course, we can see this is pretty acidic, which makes sense because HCl is a strong acid. So that's always a hint, right? Make sure that your answers make sense. So with that, we have our pH. Hooray! So our pH is there. We can do other things, though. We can figure out the OH minus concentration, because sometimes that's important. Maybe we want to focus on the OH minus. What about OH minus? Well, we know how to do this, maybe. If you remember our auto-ionization of water, as this equation is called, remember that the K for this equation, which is Kw, is H plus times OH minus, which was 1 times 10 to the negative 14. So if we have H plus, we can find OH minus. We just plug it in. So OH minus, therefore, is Kw over H plus, or in this case, I'm going to actually put Kw here just so we remember. So 1 times 10 to the negative 14 over, what was it, 0.0262? Again, we don't need to really worry about units here. The units should be molar, always, thankfully for us. And then pH and pOH, as we'll see, foreshadowing, will have no units. So if we go ahead and do this, 1 times 10 to the negative 14 divided by 0.0262, we get 3.8, we'll say 816, but we have 3 sig figs here, times 10 to the negative 13 molar. So very, very small OH concentration. And guess what? We have a new term we can use. We could say we can also find the pOH of the solution, which is simply the negative log of the OH instead. So same thing as pH, except now we're focused on OH minus. So we don't call this pH, it's now pOH. power of hydroxide. So negative log of this number equals 2. Let's go ahead and do this here. Negative log of answer. Oops, sorry, I put the wrong button. Negative. Fine, I'll actually type this out. Okay, 3.816 to the negative 13 power. Here we go. 12.418, we'll say. Again, 3 sig figs. Do not be bamboozled that 12.418 appears to have 5. It is a logarithm, so that number only has 3. Now, interestingly, if we see our 1.582 and 12.418, just for funsies, let's add that together. Let's just do this for fun. We had 1.582 plus 12.418. Oh, we got 14. Now that's curious. But it should be expected, because if we remember our equation, H plus times OH minus equals KW, which is 1 times 10 to the negative 14. If we take the negative log of both sides of this, negative log of H plus, remember, if you're multiplying things, if you want to log them, you want to do log, those are added together. So plus negative log of OH equals negative log KW. This tells us pH plus POH is 14. And we can say that this is with 3 sig figs, that's fine. So that's another equation that we have here. And with this, once we know the pH of something, we can calculate the pOH very easily. Just subtract it from 14. And so another tool we have added to our toolkit. And the last one I want to go over is how we go from pH back to H plus concentration. So we know how to go from H plus to pH, right? We just take the negative log. But we're going to see that H plus by itself will be equal to 10 to the negative pH power, whatever that happens to be. So it's the inverse of the negative log, will be 10 to the negative pH. So if we have our, let's say our pH of 7.4, our blood, H plus would be equal to 10 to the negative 7.4. And so if we go ahead and do that on our calculator, 10, notice, by the way, this will be your anti-log button. So usually it's the second of the log. So second log, negative 7.4. Notice we get 3.98 times 10 to the negative 8 molar. So that's how you go backwards. And guess what? It's the same for pOH. OH minus concentration would be 10 to the negative pOH. All right then. OH minus is simply 10 to the negative pOH. So, we can do this. Relatively simple calculations, but you should be able to interchange between these. Given pH, you can find H plus, OH minus, pOH directly. You can do it all. So given one of these numbers, you'll be able to figure out the rest. Let's summarize this section of kind of the practice here by putting all our equations in one place. Make this nice and easy for you. So pH is negative log H plus. All right, pOH is the same thing, using hydroxide instead. H plus will be the inverse, so 10 to the negative pH. OH minus will be 10 to the negative POH. We have Kw equals OH times H plus. And finally, we have pH plus POH equals 14. So, and don't forget Kw is 1.0 times 10 to the negative 14 at 25 degrees Celsius. Pretty much all of these we're going to do at 25 because I don't want to mess with this constant for us. So these are the equations for kind of this section here. So these ones you'll want to focus on. Make sure you know how to use them on your calculator. So actually bust out your calculator and do these. And make sure you know when to use them, right? Like if you have pH and you're solving for H+, there's no need to find POH, right? Unless I ask you for that. So just make sure you know how to use them. Ask questions, as always. So with this, this will be kind of the end of the math part of strong acids. We're going to shift back towards equilibrium, and then we'll bring some of these ideas back in. And that'll be in the next video.